introducing Bart Hommels. He's a physicist and has been a Open Eco Homes host. In 2019, he was able to give in-person tours, and last year with an online tour of his really inspiring retrofit of their 1940s semi. And so it includes an extension that's been made to Passive House standards, and it was all achieved with lots of do-it-yourself DIY. So now he'll talk about the easy wins and the basics of retrofit. So over to you, Bart.
What is retrofit actually all about? Some people do it to get a better and more comfortable, cozy home. Others do it mainly for reasons of cost savings, and others are doing it for reducing their carbon footprint. And of course,
your screen share is, or maybe you haven't gone there yet. We're not seeing one big slide at the moment.
You don't? Okay, then I should stop sharing and get the right one to share. It should, is it this one then?
Yes.
Ooh. And you can see them changing as well, hopefully?
Yeah.
Okay, here, this is where we were, I think. So yes, so people do it for different reasons, the cozy home, the cost savings, and the reducing carbon footprint. And of course, the best measures tick at least 2 boxes, and the holy grail, of course, is to tick all 3. But it's just to sketch out that one is not necessarily the other. We'll get to that in a minute a bit more. First of all, the basics. We've all heard about insulation, and we all know more or less what it's for, I reckon. It's to keep the heat in, or in a heat wave, keep the heat out. But also hot water systems deserve our attention for insulating better. Then, if you insulate, you also have to think about ventilation. We have to keep our indoor air healthy, but also minimize the heat loss while doing that. And of course, drafts are everybody's enemy. Nobody likes those. Then, one thing that also deserves attention is controls. Match the heating to what we want and what we need. And not only the central heating, but also the hot water. Have hot water ready when you need it, but when you don't need it or you're not home, then actually maybe the controls can do something to save energy there as well. We can talk about energy supply, as in retrofits to your home. Take care of your own supply by introducing solar PV to your roof, solar voltaics. Solar thermal is another option, which is not mentioned in this bullet list. Solar PV, the electric version, is nowadays sometimes combined with a battery. And of course, the heat pump for the delivery of heat is another modern option that is now gaining popularity. And last but not least is behavior. As habits are hard to change, but it can be done. There is always the comfort creep to combat, where every year you put the thermostat of the heating a bit up because it's so nice. And of course, you can't really manage what you can't monitor. So monitoring is actually, in my opinion, quite a nice thing to have. And with smart meters, that is coming to everybody's home. So first of all, insulation. Retrofitting is actually all about measures. And in the top left, you see a picture of radiator foils. Now, I must admit, these don't help that much, but it is a measure and it doesn't cost much either. So for the cost benefit is actually quite good. They will sort of earn themselves back, if you like, within a very short time span. The same actually goes for hot water cylinder jackets. If you have got a hot water cylinder, even ones with a bit of foam sprayed on, then a hot water cylinder jacket will insulate better, reduce the heat loss. There's no loss of comfort or functionality, but it will save you money. Then there is the obvious other candidate is pipe lagging, so surrounding all the pipes with insulation. And I'm not just talking about the hot water pipes, but also the central heating pipes. If your central heating is on and you call for heat, you don't really want to heat your floor voids, you want to heat the rooms. So the hot water should be delivered where it's needed and not anywhere else. While you're at it, it's a good idea to insulate cold water pipes as well, because otherwise they will attract condensation and you get moisture where you don't want it. Now, these measures, especially the pipe lagging, you can have the most advanced high standard passive house and it will still have pipe lagging. So it's a thing that everybody, well, in my opinion, should do. Then if you're talking about other high benefit options that carry very low risk, because of course, with all the changes to a house, especially with older properties, there is a risk associated to any measure. So you should think twice before you do anything, but the things I've mentioned here are very low risk. And of course, loft insulation top up to 300 millimeter, and possibly there's still grants available for that, is a high benefit and low risk option. It can be done DIY. It's not very difficult, I would say, but do make sure your loft is safe to work. And then if you go further, there is a cavity wall insulation, triple glazing, but actually that becomes rapidly retrofit plan territory where Carl is more the expert than I am. If we're talking about insulation is quite simple to understand, isn't it? I mean, but then ventilation is a bit more tricky because we all need insulation and homes are designed to building regulation standards with certain ventilation rates in mind. We need a healthy indoor climate. We need to remove stale air. We need to let fresh air in. But how much? Well, building regulations details this. They specify the minimum ventilation rates for dwellings. And it also depends on what your house is equipped with. And this has, of course, changed over time. There used to be open fires and gas appliances with open flames, meaning that they need oxygen and they might produce CO2 and CO, maybe a bit even. So that needs to be taken away. So more ventilation was needed for those. Another aspect is to keep the building in good condition. And that's why there's still a requirement to have ventilation under suspended timber floors. And nowadays, of course, also, more modern wet rooms, when those were introduced back in the days, extractor fans are now required for bathrooms, cloakrooms, and so forth. So these are all ventilation requirements that have different functionality, in fact. If you want to check whether your ventilation is what it should be at the minimum level, then Cambridge Carbon Footprint now has CO2 monitors to check your ventilation rates. And the nice thing about these is that they measure humidity as well. So this is the good thing about insulation. Now the bad thing. Of course, you should not sort of completely stop ventilation because that's, we need the healthy air on the inside as well as on the outside. But of course, you need to eliminate heat loss from excessive insulation. Insulation ventilation. That's the ventilation that is not designed in. And you can do this by, on a windy day, go with your back of your hand around these areas, around the window and door frames. The underside of windowsills are a notorious one. The perimeter, where the floor meets the skirting boards. You might have worn out window seals that let air in on a windy day. Especially notorious as well are the ceilings in airing cupboards, where there's loads of pipes and other cables and what have you going through the ceiling. Unused chimneys, often forgotten about, but a very big hole in your house basically that can take warm air out and let cold air in. But of course, again, I can't stress this enough. The desired ventilation should be there, so you should keep air bricks and vents that are designed in. You should keep those open. In the dashed box, there's a few measures that you can. There's a few products you can use for the different for addressing these things. For example, around windows and door frames, you can use caulk or sealant, draft excluders, and these kind of things. And if you're getting a bit more serious about it, especially for airing cupboard ceilings, you could think about expanding foam. And if you're serious about like that, then please go for a gun and not a single can, because the guns are much nicer and well controlled, and it gets a lot less messy. Chimney balloons are a very nice solution that can be put in and removed depending on whether you need the chimney or not. And there's a link on this page to a web page, set of web pages that has much more information on them. Then controls, both for your heating and hot water. These have come a long way since the old Honeywell bang bang switch with even a bit of mercury in, I believe, in the first models. Now we've got all kinds of smart thermostats available. There's solutions for every budget. There's replacements for your current thermostat that will be like a drop-in replacement, no extra cabling needed or whatever else. And some of them have very advanced features, not only time and temperature control, but also these things can decide autonomously based on movement sensors or you know, the location of your mobile phone. They can decide like, oh, you're not home. You know, I go back to the minimum setting and wait until you're in again. And we shouldn't forget about hot water cylinders if you have those. Of course, lowering the temperature is not much of a problem in most of the cases. There's no need to keep it at 70 degrees all the time. But of course, 50 degrees might be good enough, but we have to worry about Legionella, and there's guidelines for how often to cycle it, to what temperature to eliminate that. And of course, it all comes down to hot water controls, to only have hot water at the ready when you need it and not when you don't, because then you reduce the standing losses, and that's all wasted energy. And especially in summer, these things can sort of leach out a lot of heat where you don't want it. Going further on energy supply, again, you could consider solar voltaics. It's generally a low risk. I mean, there's a lot of experience in the industry now. There's high benefits. Well, we only have to look at what the electricity prices are doing at the moment. These systems like this can be combined with a battery. The main aim there would be to use more of your solar energy, and as a side effect, you help the grid flatten this notorious 5 to 9 p.m. peak when everybody starts cooking, putting kettles on, and so forth. Unfortunately, the prices of the batteries and the scale of it is not really or barely making it economical. So if you have the budget, you might as well look for other measures. You know, if the choice is between nice triple glazing or a battery, then probably you should think twice before shelling out on a battery. They are barely economical, but they do exist, and the systems work as they are promised at the moment. Then, of course, a lot is said nowadays about heat pumps. These will probably result for most people in the largest reduction you can make in your energy consumption, and even larger reduction in your carbon footprint. So they tick two boxes, very loudly, if I can say so. And the link there contains more information. Then the most difficult one is behavior. I think in a recent study, it was seen that even the Department of Behavioral Sciences of a well-known Cambridge Institute of Higher Education could not change its behavior. So it's a really tricky one. But of course, we can all wear warmer clothes and turn down the thermostat a little bit and save energy that way. Instead of long baths, have short showers. Water is very energy intensive to heat. And of course, that will save you a lot of energy as well. Nowadays, with smart meters available widely, you can monitor energy use quite nicely, and minimizing it is a lot easier when you know what you're talking about. And then there's loads more to explore and learn on the Cambridge Carbon Footprint website, for which the link is included. And I think you should stay tuned for the home improvements that go beyond the quick and easy I just presented. Thank you very much for your attention. Happy to take questions.
Thanks, Bart. That was great. So, Chris, have we got questions?
No, we haven't got any come in yet on the chat. So the floor is open in a sense to people who want to put questions.
So Bart, I was wondering what monitoring you're doing at home,
Well, it's this is actually how I got started a little bit, because when I moved in the house I currently live in and did a lot of work on, I bought one of these standalone energy monitors. And then I noticed that my immersion heater for my hot water came on for like 20 minutes every 2 hours. And at first I didn't know what it was. I saw it in the graphs. There's something that uses like quite a lot of energy every 2 hours. And then I started hunting the house for what it was. I came out on the hot water cylinder. I bought a jacket for it, and then it only came on 20 minutes in 3 hours. And then, of course, the game was afoot. Then it was the sport to make those intervals as long as you could. I bought another timer clock to switch it off at night, so it wouldn't keep my cylinder hot all night when nobody's using hot water. So that's how I got sort of that's where the obsession started, I can say.
Okay.
I don't have the original monitor anymore, but I have a smart meter now, like most other people.
Hi, we've got a question come in from Anne-Sophie. Would she like to unmute and put a question to Bart, please?
Yeah, it's probably a silly question. I had heard about pipe insulation and the especially the central heating pipes. But okay, I've got a house, a Victorian house with several floors, and I was thinking, well, you know, if the pipes heat up between my ground floor and first floor, I thought it was okay actually, but it's not really heating the floor and being beneficial there. You're saying you want to remove the floor, insulate all this, and only bring the hot water to the radiators. Is that what you're saying?
I would say so, yes, because
Yeah.
especially if you have long pipe runs and your water loses heat, so your water will be cooler by the time it arrives at the radiator. It won't be much, but it's just that little bit.
Okay, no, I've never thought about it. That's good to spell it out.
I'm not sure whether you should take up your floors, especially if they have a nice finish, just for this. But you know, the picture there is when I had to do work there anyway.
Yeah,
The cable had to be laid, and then I saw these bare pipes and thought, like, oh, you know, let's put some insulation around them.
Hence the planning. We did bits on the floor last year. I could have done that, but next time.
Yes. Oh, you know where the screws and the nails are now, so that makes it a little bit easier.
Yeah, and it's going to be a tricky job. There's lots of them. Anyway, I don't want to digress and take from your time. It's very interesting.
Thank you.
Thank you. There's a question come in from Ali, and wonders if you could say a bit more about ventilation. She says she's had some mixed advice about when an MVHR system is a good idea and when not necessary. Is that possible? Could you say?
Yes. I went the whole hog and installed an MVHR, and I think they are fantastic. They are really good. They have more benefits than just economical. They cost some energy to run, so that but it's not much. You know, they keep the fan spinning all the time, so they do consume electricity. They do save heat, and for me, the best thing was that they provide a whole house flow plan. You know, before it was left to the weather, it's more like if the wind is blowing outside, you get lots of ventilation. On a summer day, a still summer day, not so much. And of course, with the air being distributed in the house a bit randomly, you could smell in the whole house within 15 minutes if someone started cooking. Nowadays, I have the MVHR and it extracts in the bathroom and the kitchen, so the smells stay in the kitchen, and you know, and there's fresh air let in the bathroom, in the bedrooms, and so on. I think it's great, but I must say, retrofitting it to an existing house, unless you've got a very grand place, it is really difficult.
I think.
Could I comment? Yeah. And it's kind of carrying on from what Bart has said. There are different ways of ventilating a house. MVHR is the gold standard, but if it's a retrofit, there's a lot of design. You can have a bad MVHR as well, which actually costs more to run than it saves. So you do need to design them quite well. There are other systems that you could use, but you know, clearly what you want to do first is insulate, so you're not losing loads of energy through leaky houses, and then the MVHR works a lot better, and the location of the unit itself is very important. So try and keep it within the envelope, the thermal envelope, and the positioning of the pipe work. The pipe works are quite chunky, and if you haven't got a lot of space, there's a lot of work trying to get them in the right place. So it's more complicated, I'd say, than other types of ventilation. But if you have a well insulated and airtight house, they are extremely efficient.
Okay, there's a question coming from Alex. This may be the last question we can take in this part of the meeting. Can you say something about air source systems and what sort of saving would you expect, and how noisy are they?
Yes, of course. There I haven't got much experience, I have to say. I haven't got an air source system myself. They have become a lot quieter. I think someone compares them, even when they're working at full tilt, at sort of a mild rain shower. So it's not that noisy, and it's a very sort of, it's not a very penetrating noise. So that, I think the noise issue is something that has been addressed over the last years quite effectively. The savings you will make is that, you know, a boiler can only burn gas once, and the heat is coming from the gas. So the efficiency can be 100% theoretically, but that is it. Now, a heat pump works like a fridge where you put some electricity in, but it can shift much bigger quantities of heat across. So a heat pump, also the air source ones, can be 250, 300% efficient, meaning that for every kilowatt hour of heat, you have to put in, for every kilowatt hour that the air pump, the heat pump consumes, you get 3 kilowatt hours of heat. So there's a multiplier of about a factor 3. That combined with the low carbon intensity of the UK grid nowadays, you know, there's a double whammy where you save on the amount of energy you need, and that energy, the source of that energy is lower carbon. But again, like Carl was saying about the MVHR, your house has got to be suitable for it. There's a bigger variety of air source heat pumps now, ones that can mimic a boiler in that they can deliver high temperature water. But a heat pump is at its best when it delivers a lot of lukewarm instead of a bit of very hot water. So they combine very well with underfloor heating if you have that. Otherwise, you might have to increase the radiator size to get enough heat, even when the radiators are a bit cooler than they used to be.
Thank you, Bart. We need to move on fairly soon. Roxanne and Steve, was your question answered by Tom Bragg's link on ventilation? If not, perhaps we can just take that one. So Roxanne and Steve asked, can you elaborate on retrofit issues for MVHR?
Can I elaborate? Yeah, it is very difficult, but I found it very enjoyable in a strange sense. You have to think very careful about the design, because also, you know, I used an external design service that used the computer software to sort of fudge the pipe in architectural drawing. So first of all, you need architectural standard drawings so they can actually fit the pipes in. But then even then, they came up with the design, and I had to sort of, you know, the tricky corners where there's loads of bends and everything. You know your house better than anybody else, so you will probably know in which nook and cranny it would fit and where it wouldn't, and that is very hard to do for a designer remotely. Then the system itself, yes, it's tricky. I can talk about this for hours, but I find it, well, together with the loads of installation I used, and I've heard this from others as well, it's fantastic. You get the fresh air you have on a spring day. You have that every day. There's no you know, stuffy corners anymore. Everything gets a bit of airflow, the landings, the corridors, you know, not just the rooms. I think it's great. Even when your house is, they also said that, you know, your house has to have a certain level of air tightness before it makes sense. I would even pay a bit of extra money every year to have it run and have fresh air everywhere in my house. And one of the biggest benefits I forgot to mention is that one household member could stop using prescription medication for hay fever. Big win.
Good.
Thank
I think we probably have to,
Bart.
Tom.
I think I need to carry on with Carl's talk now. So I've known Carl Dodd for ages and admired his design and project management of numerous eco builds, including a recent award-winning retrofit of a big Victorian house. So I'm looking forward to Carl telling us more about whole house retrofit. Over to you.
Yes, thank you, Tom. Hopefully you can hear me. Can you hear me?
Yes, we can hear you. Yes.
Okay, sorry, I'm going to share my screen again. Thank you. Hopefully. Good. Right. Thank you, everyone. Right. So yes, thanks, Tom. Hello, my name's Carl, and thanks for inviting me to talk tonight. As Tom said, we've known each other for a long time. I have been involved in designing and managing and doing green projects and energy projects for decades. So my interest went back to the late 70s when I was 10, watching the television and seeing all the three-day strikes. So I've been very interested in it a long time. I trained in the Royal Engineers in the 1980s, but I've been an architectural technologist, a chartered builder, project manager. So I've really got into this. My first taste of retrofit projects was in the 1990s. I worked for a housing association, a local authority, and I was responsible for improving hundreds of houses, well over 300. This was the early days. We didn't call it retrofit, we just call it refurbishment. And so it made a profound impression on me. So I'm going to spend a few minutes talking about what retrofit is, but also the latest standards in terms of large-scale retrofit and things that I think might be useful for people to know about. The little slide there is just kind of one of these facts that what we should be doing is retrofitting and not building new. We'll reach our 2050 targets faster, and a refurbished house by 2050 would have saved more carbon than a brand new one built today. So that's quite interesting.
Carl, we're not seeing your screen share.
Okay, I shall end that. I'll have another go. Can you see it now?
That's good now.
It's good.
Thank
Are
you.
you able to see it now? Yep, full screen.
Yes.
Okay, thank you. I'm not very good at Zoom. I found out much more used to Teams. Yeah, so I'm going to spend a few minutes talking about various parts. So can you see this image of a barn conversion? Yeah.
Yes.
Okay, so the little fact on there, and there's a little link to it, is that it's, as I said, it's actually better to retrofit now, and that would save more carbon by 2050 than if you built an energy efficient house. So that's a kind of good thing to remember. So one of the topics was what exactly is retrofit and what drives it. I mean, I would say, why would you want to spend such a lot of money improving your home and trying to come up with a good solution? Retrofit is different to a general repair and renovation project because a retrofit focuses on saving energy and accounting for carbon, reducing a carbon footprint. We all know that the UK housing stock is in very poor state. 85% of the housing stock will still be around in 2050. So I think it's important that we do, as a nation, we should do something about it. So I think the main drivers for doing a retrofit is obviously to save money on bills, and with the latest news about rising gas prices, it's very topical at the moment. But we should also consider whole life cycle costing, including carbon. The other is, I believe that people are motivated by adding value to their home. I don't know whether that's current at the moment, but I think that going forward, houses that are better insulated and more energy efficient will be worth more than their leaky counterparts. As Bart has said, you could be improving health outcomes, certainly indoor air quality, and many homes still suffer with damp and mold. So this is what a retrofit program can do. And I suppose the other one is ideology. You might actually want to save the planet and reduce your carbon footprint. I think, in my experience, it's always more complicated. People have got other needs. They tend to want to improve the house as well. So this is generally a good time to do a retrofit. So I feel that most of the ones I've ever got involved in, it's because there are other drivers, but it's a good time to do it because the disruption, depending on how much you're going to do, is part of your general build anyway. So the slides I've got here are a typical 1930s 3-bedroom semi-detached house in Cambridge. The client wanted to remodel the house. They'd moved in, they wanted extra room for a growing family. It needed quite a few repairs and changes to the kitchen and bathroom. So it started off as a renovation project, but the client was also very keen to explore energy efficiency to reduce the running costs and make the house more comfortable, which is kind of the benefit as well. So at the time, I mean, this is going back a few years. It wasn't possible to do a full retrofit, but you know, one of the themes of my little talk is that we'd allowed for the possibility of future improvements without disrupting the work we'd already done, and we weren't going to have unintended consequences of doing an improvement and then having to rip it out because we hadn't thought about it early enough. The house, when we started the project, was an EPC of F, which is quite poor. And we had a fabric first approach, and we certainly did all the work we could on the rear and the side of the property, and we upgraded to a much more energy efficient condensing boiler. We used an external wall insulation system. The extension was built out of structural panels, structurally insulated panel SIPs, which some people may have heard of. We upgraded all the insulation. We put a lot more, as Bart was saying, we've got a lot more air infiltration. We dealt with that by sealing gaps and holes that we didn't need. And then we replaced all the windows. So eventually what we ended up with an EPC of a C with further plans to put solar PV on the roof. So I think what most people tend to focus on is the cost of energy efficiency measures, and they don't see it reflected in kind of the value of the property. But if you do it as part of a general improvements to the property, often it's more cost effective and it can be built into the renovation costs. So I suppose the question is, why do you want to do it to your home? Well, all the above are good reasons, but realistically, if you want to do a whole house retrofit, you need to follow a system and you need to think about a plan of action. This has now been enshrined in the latest, they're like British standards, but they're called public accessible standards, of PAS 2030, which is the install part of it, and 2035, which is the professional planning and monitoring of the works. And that's essentially, this is the new standard, new specification for a whole house retrofit. I'll move to the next slide. So the slide shows essentially the latest standards, and I put a couple of links in there if people want to find out a bit more. So the PAS, like I say, 2035 is the guidance and the specification. 2030 is all the measures and typically the install quality and assurance. We also need to take into account that a lot of our housing stock is traditional build, solid walls. The 1930s house we just saw was a solid wall, and that will be more governed by the British standard that covers that, which is 7913, which again, you can find copies of it online. Every retrofit project is a bespoke project. You need to understand the building. We talked briefly there about, obviously understanding, the age, the characteristics of your house, and also what you want to do, how far you want to go along this retrofit journey. So basically, properties fall into two categories: modern building, which is a cavity wall type construction, and traditional and heritage, which tend to be a solid wall. So you need to bear that in mind. They're two distinct ways of building, and they require different thought processes and measures depending on which one it is. PAS 2035 became a mandatory requirement as of June of this year for companies who are installing energy efficiency measures that require funding, public grants, public funding. And the reason it's come about is because the industry traditionally suffered from many issues, such as poor quality installations, defects that they have to come back and sort out, and there was no accountability for the work. So it was kind of the quality of the work that was coming, and often there was no engagement with professional designers or advisors. And there was always a performance gap. Whatever you were promised didn't actually materialize in real life. So the government, following Grenfell, started to realize that they needed more quality standards, particularly with retrofit. And it needed a framework that could deliver wholesale retrofit programs, not just individual homes, but obviously countrywide, and encourage people to trust the install market with a quality standard. So that's what this PAS 2030, 2035 is about.
Carl, I think you're going to have to speed up a little bit to
There you
make
go.
time for
Well,
questions.
I've gone on my next one, which is
Right.
the roles within PAS 2035. These are professional roles. So essentially, I put a little link so you can find out a bit more. The ones that most people won't understand is retrofit coordinator, which is like your project manager, professionally qualified project manager. Their job is to manage it from end to end, and they have a duty of care to the client. You have an assessor who's like your surveyor, who will do that measured survey and will start to prepare the information that your designer then produces those plans. So these roles are key to understanding what the PAS will deliver. I'm not going to labour what each person does, but there's very specific roles and very specific qualifications they need, and you need to check these. So part of the PAS is to have a long-term, a robust medium-term plan, and it requires a lot of planning, risk assessments. We've talked about risks, low risks, medium and higher risks, and it actually identifies which routes to take and which designers and project team you need. And it's all tailored to obviously the client's requirements and the house itself, which measures it needs. And this is an iterative process. So, often this is about considering the impact of all the measures, not just one-offs. And you can do this over a long period of time. This plan could last for 25 years. So it's important to remember that whatever you do today may have an impact on a later improvement, and you need to understand which sequence to do it in. Often you have certain measures which have to work together. You wouldn't replace your windows and then go back and do an external wall insulation, because your windows would probably be in the wrong place and it's much more difficult to work around it. You'd probably do those measures together. So low-hanging fruit is a kind of an analogy that you would you'd have to understand which measures are worth doing in terms of their payback and also their sequence. So this is the example of the historic deep retrofit, and a client who was very keen to go as far as possible. It was a very old rundown building built in the 1840s. EPC was a G, worst possible, and the worst one I've ever come across. And it was very historic, and we wanted to retain a lot of the fabric. And the idea was to come up with a long-term plan and a plan to get from a G to an A, which is what we did. And it took a year of planning, designing, measuring, going back, looking at the costs, making sure that we had actually proposed a sort of a whole package that would actually pay for itself within 10 years, which there's a whole story that I won't bore you with it. But essentially the strategy that we took was to repair it, make sure it didn't leak, restore it, get all this of the historic things, and we had to treat it like a listed building. Then we retrofitted, and then we rejuvenated. So that again took a year to think that through, and a year of restoration. The client didn't live in the property, which was lucky, because we tore it to pieces and then put it all back together. So as I say, we entered this into the FMB Master Builder of the Year. We won the regional Master Builder of the Year for this project. So it's possible to do it, but you do need deep pockets. I'm going to move on. There are lots of things about this, and we spent a year afterwards. We monitored the performance of the property, and we did a sort of an evaluation at the end, and we had a sort of bit of an interview with the client, and we did that last month actually. So that's really important, that whatever you say you're going to deliver, you can monitor it and then prove it, and you're accountable for it. That's the whole point of this, that your professional team are accountable for it. Right, I'll just move on to the next slide. Again, more modern property, again, needed a plan. This is a 1950s in Cambridgeshire, 1950s cavity wall, very run down, a bit sad. We extended it with another SIPS extension, replaced the boilers, put a lot more insulation in it, ventilation. So all the things that we've discussed so far were done in this. It was again another 6 months of planning to get all the contractors on board, the specialist equipment ordered, and it was a 5-month project. So again, whole house done in stages. Contract value, actually it was in excess of 100,000, but it was extending it and remodeling it. So the cost of the actual energy efficiency measures, and the retrofit was built into that. So it was probably added another 5 or 10% to the actual project cost. I use this slide here just to sort of show that when you have this retrofit whole house process, there are measures and interactive matrix. As you can see, I've just blown up a section of it to show which ones work with each other. So green, basically it doesn't interact, it's a simple measure. And the traffic light is obviously amber, you need more detail, more thinking, and red is measures that you don't mix together because they just don't work, they counteract each other. You do need some expertise to use this. It is available. You can find this matrix online. There's lots of ways of interpreting it, but you probably need an expert just to guide you through that. So I've just given you a really quick summary of what PAS 2035 is. It's a sort of a professional project managed way of doing it. It has the plan, the robust plan, which essentially takes all of the issues that you have. It goes through a process of surveying it, kind of understanding it, putting forward measures, testing iteratively, and then when it's on site, it's like having a clerk who works there who will make sure the work's done properly and monitored, and then obviously assessing whether there's defects and things that need to be sorted so you get what you were promised. I think it's a very good standard. One of the takeaways is, as an individual homeowner or as a simple retrofit, there isn't at the moment any requirement for you to use this standard or even the recommendations in it. But if you're seeking funding, it'd be wise to understand it. My principal concern is, I think, to avoid these unintended consequences, and you should be confident that the installers who come into your property to do this work, if you're not going to do DIY, of course, are suitably qualified and competent, and they're held to account. And there is a standard, a quality standard, and that's what this is all about. It's run by Trustmark, which is the government accredited scheme. And I think if your project gets really complicated, more than just a single measure, you should consider having some type of project manager to help you run and obviously deliver what you expect. And I think the other takeaway is to understand that essentially there are two types of domestic building. You get modern constructions, which are treated differently and designed, and the measures are different to a traditional building, which is essentially a solid wall because of the way that they were designed to be heated and ventilated. On the slide, I've just shown you kind of the core principles, which is the accountability. It's a whole house solution. You build tight and ventilate right, which is kind of what we've been saying all along. And there's a strong focus on quality and making sure that things are delivered in a way that, you know, you have accountability. So that's the end of my presentation, but I'm happy to take questions, and thanks for listening.
Thanks a lot. Chris?
Okay, we haven't had any queries come in on chat apart from yours, Tom. So perhaps you want to just raise that.
Well, you had me thinking, Carl. Have you got any advice on finding and choosing a retrofit coordinator? I know that may not be easy.
The PAS has not long been in existence, and typically what they've done is they've issued lots of information, but they haven't trained the workforce or enough coordinators. And I looked on Trustmark's website before I started this, and they've only got 31 listed throughout the UK. I know there are a lot more of them, but it does make it difficult to find good quality people who know what they're doing and they're professionally qualified. I think if you're looking for somebody who has done the appropriate qualification, that's level 5, which is sort of degree level qualifications in terms of project management and retrofit. That's useful. You can find them on Trustmark. I think if you're talking about the installers, they have to use the PAS 2030, which means that there are accreditation bodies and trade bodies who can do this work properly. but I think that the first port of call is you know, look it up on the internet and go through Trustmark, which is the kind of the source of knowledge. There are some people who are already doing retrofit coordinators. I think it's designed really for larger projects, and the idea that the risk is managed. Like I say, you might be spending quite a lot of money to do a whole house package, and that gives you the sort of the accountability that you should really have if you're investing so much money, and obviously deliver the kind of impact and the savings that you've been advised you can make. And I think that's the difference. You can do quick wins, but once you start to get into the complexity, it's finding them. I'd say Trustmark initially. Retrofit Academy is sort of an organization who are doing the training, and they're also we hope we're going to hear some news from the government that they're going to start funding this in a significant way. I think this is of a scale as big as HS2. They should be putting billions and billions of pounds into retrofit. We should consider it a national project, but that's just my view. It's what I'm basing my future on, that I hope that we will do a lot more retrofit, and it will be whole house, and it will be sort of long term, not just a sort of a fad. I'm very skeptical of this government's ability to deliver and do what they say they're going to do. So
thank you, Carl. There's a very general question which I think I'll postpone till perhaps after the end of the session, and you might want to take it up then, which is to ask about advice on all the people you need to find, architects, builders and trades. But for the moment, let's move on to a question from Danielle. Is it common for builders and contractors to understand the correct measures for solid wall stroke traditional homes? Or do you need to look for companies that expressly specialize in these types of property?
Yeah,
Danielle.
Yeah. It's a good question. There are trade bodies where people are qualified. There are certifications you can find. General builders, I have to be honest, no. I think that they understand some bits of it, but they don't understand this unintended consequence. Insulation, you need to understand the building as a system. So if you super insulate your house, you need to think about ventilation, and a lot of the contractors don't really know that yet. That's why you need the site supervision. That's why you need to kind of establish what you're going to get before they start, because often they'll do things maybe with the best intentions, and it has a knock-on effect. There are trade bodies. General builders, I would say, even if you get a recommendation from somebody else, I would say we need licensed contractors now and retrofit specialist installers, particularly with insulation. We've had too many problems in the past.
Thank you, Carl. A very pertinent question coming up relating to costs from Anne-Sophie. Supposing one has a house you want to improve, but don't know what is possible in your case, where do you start, and who do you go to who doesn't charge a lot up front?
I think Cambridge Carbon Footprint's a great resource. Plugging your organisation here, Tom, but I think there is lots of advice. But if you want professional, impartial, independent advice, there is a retrofit assessor and there is a retrofit advisor, and these are the first port of call. There aren't too many of them about, so there are other ways of doing it, but I think you have to invest a little bit to understand what you're going to do. You could spend a lot of money and get it wrong. That would be my worry, that you might have a partial advice that isn't the whole house kind of solution. So I understand where you're coming from, and there are quick wins, as we've said, but if you're kind of looking at the long term, and you have to think about it, the property as well, it's got to be right for the property. It's not just a case of just adding more and more insulation. It might be the wrong kind of insulation. So you do need good advice, and you may have to invest a little bit in that.
Thank you, Carl. Let's point out that Tom has put in the chat a link to a set of the slides which have been shown, a combined set from the two presentations tonight. So you might want to look at that link later on. Next question comes from Chris Carter. Very straightforward. Where can you learn to plan retrofits yourself?
You can go on the course. There's nothing to stop you doing the course. I think there are some minimum levels. So I think if you don't understand building, it might be a little bit overwhelming. But Retrofit Academy is good. They do lots of information. I think that's I would probably go to a professional FE college or something like that to understand building in a bit more detail. I suppose I'm always going to say that because I come from this professional background where I don't necessarily think doing everything yourself is a good idea if they're quite sophisticated, risky things to do. But you can go on courses to do it.
So Bart, how did you learn?
Yeah, I was. Of course, I've got something to say on this. The higher the specification of the retrofit, the more tricky it becomes to get it right. I have to admit, of course, yes, I've done a lot myself, but initially I went for the extension as well to an architect who delivered a whole house plan. They ran the house through calculations because I wanted to make absolutely sure that I wouldn't run into problems like summer overheating, like Carl was saying already, alluding to the problems with moisture, humidity, migration through the house. I wanted someone who was very experienced in delivering these kind of retrofits. And then why did I do lots myself? Because tradespeople with the right skills are incredibly hard to find. And I've got the natural physicist arrogance of thinking I can do everything.
I'm not saying you can't do it yourself. I don't want people to think that it's impossible. I just think that you did the right thing, but you recognize that what you didn't know, and you brought someone in who could give you solid advice, who was accountable for that advice as well.
Well, accountability, of course, is difficult with architects because they can't pin them down. But if you plan a very high specification retrofit, there are some standard recipes, but you can still go wrong. And I personally, I've done loads myself, but the whole planning, I maybe wouldn't.
So I think I probably need to move on to the closing slides now, so that we finish at 8. But as we mentioned, it seems like there are still some questions, and so you're free to leave in a bit at 8, but we will have some extra time if you want to carry on, stay with us for some more questions and discussion. And so I'm just going to share this. And so, here we would really value feedback from you about this evening's presentations. How has it gone for you? And indeed, are there ways that we can do it better another time? We want to keep improving. And so here's a link to a feedback form that Chris has put in chat. So please, it would take you probably less than 5 minutes to do this feedback. We'd really value it. And I'm asking, as we often do, for a donation to Cambridge Carbon Footprint, the charity behind this. Thank you if you've already made a donation, but if you'd like to, that would be brilliant. We really rely on getting donations, and we do also have some funding from sponsors. Thanks to them, that we rely, donations is a significant part of our income. And if you're on social media, please share what you've enjoyed here on #OverlyGoHomes. And final slide. Oh no, further resources. So I'm not going to read all these out, but and you will see this in your slide set. You can click on these links, but in particular at the top there's a Cambridge Carbon Footprint web pages about getting started with your retrofit you may find useful. And you can borrow a thermal imaging camera. Go on the website and you'll see where to do that. We will train, you can come for a 2-hour training session first, and then you can borrow one of Cambridge Carbon Footprint's thermal imaging cameras. and you might want to get political at the end there. Of course, the individuals can do a lot, but we need to persuade our politicians to give us the big time support we need. So, so thank you. I think we are going to close this main session now. Do feel free to leave if you want to, but we're just going to have a few more questions now. And are there more, Chris, that you want to call out?
Yes, Roxanne and Steve were really asking for as much advice as possible on the range of people you're going to need in a retrofit, so architects, builders, other tradespeople. Don't know whether Carl can deal with that one. Really just any helpful tips you can give on that front, I think. Okay,
so in one of the slides, I show the people who are identified in the PAS. So think of it traditionally, you'd send in a surveyor to do the measured survey, get all the information about the property, and that person is an assessor. You need someone to give you the initial independent advice, and that would be a person who's also qualified to do that, and they're an advisor, retrofit advisor. They can't really work with the installer though, because you're not really getting independent advice. The coordinators, your project manager, depending on the scale and scope of it, think of it as a person who deals with all your problems from end to end and links all the other people together. So they have a duty of care. You need a designer, which could be an architect, it could be a technologist. They can work directly for you, or you could employ a company to do it like a design and build type package. During the actual installation, I always think you should have what was traditionally a clerk of works role, the guy who goes around and makes sure the things have been done properly. In the PAS, that's kind of identified as the coordinator, but you could have somebody else doing that role as well. And what's different is mostly when you finish the contract and your installers have gone, and it depends which measures you're going to put in, of course, that tends to be the end. And then if you've got a building contract, you have a period of time where there's a defects period. What PAS does is actually make sure this monitoring and evaluation carries on for several months. And then you can go around with your thermal imaging camera to make sure that you got everything that you thought you were going to get, or you can do other tests. So those are the kind of roles which you'd normally expect in a whole house retrofit. And again, you know, it's covered under subcontractual arrangements, but that's the quality standard that you should be aiming for.
Bart, do you want to comment on that at all?
No, I think that's very wise words.
That's good.
Thanks.
Okay. Short question came in from Claire McRae. What is Cambridge Comfort? I'm not finding a link. Is it the comfort creep you're talking about, Claire? I'm wondering. Not sure. From Bart's slide, Cambridge Comfort.
Oh, did I misspelled something?
Maybe I misheard, but I thought there was a comment about Tom's company, Cambridge Comfort, might be a good one to go to, or something like that.
That was made Carbon Footprint. I've gabbled my words. Sorry, Cambridge Carbon Footprint.
Oh, okay. So the very organisation. Okay, brilliant. Thanks.
We've cleared that one up. That's good. Bart, in the chat, you've probably spotted, shows that AECB offers courses that can teach you about planning retrofits. AECB, Bart?
It's a difficult one. It's the conscious building is the CB, and the A is an architect. But what the E in the middle is, I'm not sure about. I'm sure there's someone who knows it on the list of participants.
Okay, right. Well, wave a hand if you can answer that one.
Easy to Google though. It's quite a well-known organisation.
Yeah.
They were quite ahead of the game, have been ahead of the game for quite a while. So they probably are one of the better providers of those courses.
Yeah. Final questions come in from Ali. If you're going for a PAS standard, do you have to use a particular type of contract? Carl.
Good question. I would say always have a building contract, even if it's a simple one. You can use JCT Minor Works. There are other ones, but get things in writing, get your specification. That's what your coordinator does. He pulls that all together for you and you sign a contract. I would never recommend starting work without one.
Good. That gets through all our questions. Tom.
Oh, that's a pound in the swear box. You're on mute.
Tom, you're muted.
Thank you. Okay. Well, thanks very much for coming and joining in and participating in this. And I hope it's enabling you to think ahead at how you're going to get going with your